So the next topic here is about the arithmetic function. So for this we have some general concept about the sum and the, you can say that, the sum and number of divisors. So what is the sum and number of divisors? Here we define two functions, some, you can say, tau of n and sigma of n, and this tau of n is basically the number of divisors and this sigma n is basically the sum of divisors. So the definition of, I can say, tau of n is the number of, you can say, positive divisors of n, and the definition of sigma of n is the sum of positive divisors of n. So here I'm taking some example and I'm going to explain you. So for this I'm letting n equals to 8 and d are the divisors of the 8. So 1, 2, 4 and 8. These 4 are the divisors of the 8. So the tau of 8 is basically the number of elements, the number of divisors here. So 1, 2, 3, 4. Tau of 8 is 4. That means there are 4 divisors of 8. Now further is taking this example and I am going to find the value of sigma of n. So the definition of sigma of n is basically the sum of the positive divisors of n. So n here is 8 and the divisors of 8 are 1, 2, 4 and 8. So the sum of positive divisors of 8, or I can say the sigma of 8, is 1 plus 2 plus 4 plus 8. So this is the, you can say, the positive divisors of the sum of positive divisors of 8. So that is 3 plus 4 and that result is 15. So this is basically the sigma of 8. So here I am defining tau of n and sigma of n. So tau of n is the number of the positive divisors of n and sigma of n is basically the sum of positive divisors of n. So I am taking this example. I am letting n equals to 8 and the divisors of 8 are 1, 2, 4 and 8. So counting these divisors, these are 4. So the value of tau of 8 is 4. And sigma of 8 is basically adding all these divisors. So adding all these divisors I have 15. So this is the value of sigma of 8. So here is some remark here, and that is, tau of 1 is basically 1, tau of 2 is 2 and tau of 3 is 2 and tau of 4 is 3 and tau of 5 is 2 and just like tau of 6 is 4. That means these are the divisors of 1. So divisor of 1 is only 1. The divisors of 2 is, I can say that, 1 and 2. So that means 2. And the divisors of 3 is 1 and 3. So 2 here. The divisors of 4 is 1, 2 and 4. So 3 here. And the divisors of 5 is 2 and the divisor of 6 is 4. So these are the divisors of, you can say, some numbers 1, 2, 3, 4, 5. Like tau of 1 is 1 and tau of 2 is 2. Like this, the value of sigma of 1 is 1. The sum of the divisor is 1. The value of sigma of 2 is 3. So 2 plus 1, 3. That means sigma of 2 is 3. Then sigma of 3 is 1 plus 3, that is 4. Now further, sigma of, you can say, 4 is 7 and sigma of 5 is 6 and just like sigma of 6 is 12. Like this up to so on. इस तरह से वैल्यूज जो हैं वो हमारे पास आते रहेंगे. फर्दर यहाँ पे रिज़ल्ट है जर्नल जो हम कह सकते हैं कि टॉ ऑफ n इज़ 2 if n इज़ प्राइम, कि ये कंडीशन मेरे पास हमेशा होल्ड करेगी कि अगर मेरे पास जो है n जो है वो प्राइम है तो मेरे पास टॉ ऑफ n हमेशा जो है वो किसके इक्वल होगा, हमेशा इक्वल्स टू 2 होगा। ये कंडीशन जो है, या आप जिस मर्जी प्राइम नंबर के लिए भी चेक कर लें तो ये कंडीशन टॉ ऑफ n की वैल्यू हमेशा क्या आएगी, 2। और इसी तरह ही सिग्मा ऑफ n की जो है वैल्यू वो क्या आएगी, n+1 इफ़ n इज़ प्राइम, कि n जो है वो जब भी मेरे पास प्राइम होगा तो सिग्मा ऑफ n की वैल्यू हमेशा वो क्या आएगी, n+1। तो these are the basic definition of, you can say, sigma and tau. Now here I am going to add, or I can write it in summation form. So that means I can write it as summation function f of d and d divides n. If this is a function, then मेरे पास सिग्मा ऑफ या टॉ फंक्शंस की वैल्यू जो है वो किससे मैं फाइंड आउट कर सकती हूँ, सिग्मा की फॉर्म में कैसे लिखूँगी, दैट टॉ ऑफ n इज़ सिग्मा d divides n is always 1, and the definition of sigma of n is basically summation d divides n d. That means these are the divisors here. So I am taking some example and I am going to explain you this thing. So here I am taking n equals to, I can say that 10, and the divisors of 10 are 1, 2, 5 and 10 here. So these are the divisors of n 10. So when I found the value of tau of n, that means, tau of n, that is summation d divides n is 1, that is equals to summation d divides 10 1, and that is equals to basically 1 divides 10, so this condition hold, here is 1, 2 divides 10, again this number 1, 5 divides 10 1, and 10 divides 10 1. So that means this result is equals to 4. So tau of n is 4 here. Now further is I am going to find the value of sigma of 10. So sigma of 10 is summation d divides n, and here is d divided. So that is the result. If I am going to check 1, so 1 divides 10 and the result here is 1, plus second is 2 divides 10, so the result is 2, then 5, then 10. So that is collectively equals to 80. So this is the value of sigma 10 and this is the value of tau of 10, I can say that. Now further we have another example. If I have n, the greater value of n, then how to calculate the value of sigma and tau. So if I am taking, we will go to the next page. So if I am taking n equals to 180, this is a larger number and I am going to find the value of tau of 180 and sigma of 180. So first we have to check whether the divisors of 180. So the divisors of 180 are 1, 2, 3, 4, 5, 6, 9, like that up to so on. These are many divisors here. So for this we don't know how many divisors we have. So for this I am going to split n into some prime factorization. So that is 2 square into 3 square into 5, like this. I can write 180 like this. Now further is, that means generally I can write it as d 2a1 3a2 or 5a3, and there are the conditions on a1, a2 and a3, and these conditions are that a1 is less than or equals to 2 and a2 also is less than or equals to 2 here, and a3 is basically less than or equals to 1 here. So these are the conditions. Now I am writing the all the possible divisors of this one. So D1, the possible divisor is when all the values of A1, A2, A3 are 0. That means 3 power 0, 5 power 0. So that means the result is 1. And the other possibility is taking like this. So that means the result is 2. Now further is D3. I am fixing this value 2, 0 and 3, 1 and 5, 0. That is 3. Then again, next divisor is 2, 0, 3 power 0, 5 power 1. So that is 5. Then 5 is, you can say 2 power 2, 3 power 0, and I can say that 5 power 0. So that is 4. Then D6, that is, I can say that 2 power 1, 3 power 1 and 5 power 0. So that is 6. Then D7, that is 2 power 0, 3 power 2, 5 power 1, that is 9. Then D8, that is 2 power 1, 3 power 0, 5 power 1, that is 10. Other is 2 power 2, 3 power 1, 5 power 0, that is 12. Then D10 is 2 power 0, I can say that, and 3 power 1 and 5 power 1, that is 15. Then D11, that is 2 power 1, 3 power 2 and 5 power, you can say that 0, that is 18. Then D12 is 2 power 2, 3 power 0, 5 power 1, that is 20. Then D13, that is 2 power 1, 3 power 1, 5 power 1, that is 30. Then D14, that is 2 power 2, 3 power 2, 5 power 0, that is 36. Then D15, that is equals to 2 power 0, I can say that 3 power 2 and 5 power 1, 45. Then D16, that is 2 power 2, 3 power 1, 5 power 1, that is 60. D17, that is 2 power 1, 3 power 2, 5 power 1, that is 90. And further is D18, that is 2 power 2, 3 power 2 and 5 power 1, that is 180. So these are the possible divisors of 180. So now here I can say that the set of divisors of 180 are. So I am now putting these values here: 1, 2, 3, 5, 4, 6, 9, 10, 12, 15, like this. I'm writing all these values here: 1, 2, 3, 4, 5, 6, 9, 10, 12, 15, 18, 20, 30, 36, 45, 60, 90 and 180. So these are the all possible divisors of 180. So tau of 180 is basically equals to all these values, D18. So that means if you count all these divisors, so these are 18. So the value of tau of 180 is basically 18. Now further is I am going to find the value of sigma of 180. So for this we need some basic formula to calculate the value of sigma of 180. So for this I am now further explaining a theorem and by using that theorem we will found the value of sigma of 180.